Okay, let's see how we all did. 5.1b extension video companies. Plan 1 and Plan 2. Independent X is number of videos viewed and dependent Y is the total cost per month in USD's dollars. So we'd had to define our variables. We had X as number of videos viewed and Y is total money. Plan 1 and Plan 2. Remember to stay organized and label what your equations represent. Y equals 250x plus 7 and Y equals 4x. If you wrote 250 as as an improper fraction, even better. Which situation represents functions? Both of them, did I get you? Each input or number of videos viewed corresponds or produces exactly one output, the cost per month. If I know the number of videos viewed, my input, I can determine the cost per month. How much would 3 videos and 5 videos cost for each plan? Well, taking a look, I organized my work into a schmancy table. Did you organize your work in some special way so that you could communicate clearly? Plan 1, 3 videos cost $14.50, and Plan 1, 5 videos cost $19.50. Plan 2, 3 videos cost $12, and Plan 2, 5 videos cost $20. Notice Plan 1 is the better deal for 5 videos, but Plan 2 is the better deal for 3 videos. That made you might want to think about which is the better deal and what advice would you give. If you watch 4 or fewer videos per month, Plan 2 is the better deal. But if you watch 5 or more videos per month, Plan 1 is the better deal. 4 videos each month have equal prices. Please don't forget to talk about every combination or every possibility when you're giving your friend advice on which plan is best for them. Awesome. Let's move on to lesson 5.1c. 5.1c is about linear and nonlinear patterns. We looked at linear growth earlier this year, so we're only going to do the first 2 pages. Let's start reading. Complete Foods, get it? A local grocery store has hired 2 different companies to design a display for food items that are on sale each week. They currently have a display that's 6 boxes wide and shown below. They'd like the center part of the display to be taller than the outside pieces of the display to showcase their mega deal of the week. The following are designs that 2 different companies submitted to Complete Foods, using the current display as their starting point. So this is stage 1, and then we go to stage 2, and then we go to stage 3. Can you draw stage 4 of this design? And don't forget to explain your process. So to draw stage 4, I'm going to start with stage 1, which is 1, 2, 3, 4, 5, 6 blocks. And the center column, now I have stage 2, now I have stage 3, and finally I have stage 4. I'll label this stage 4, and I'm going to write 2 additional blocks, or boxes you could say, are added to the, where are they added exactly? Oh, it's the center column each stage. Excellent. So let's continue looking at this. Can the relationship between stage number and number of boxes in a stage in this pattern be modeled by a linear function? Create a table, graph, and equation to support your answer. Let's first look at the table. The table, I'm going to have stages 1, 2, 3, 4, and 5. And remember, stage 1 had how many boxes? That's right, 6. Stage 2 had how many boxes? That's right, 8. Stage 3 had 10, and 4 had 12, and 5 had 14. So let's see, does this table show a linear relationship? When we're looking at a table, we want to look at the first difference. As x increases by 1, is my first difference constant? Y increases by 2. So I can say, yes, the table is linear because it has a constant first difference. Go ahead and write an equation that represents this situation. Remember, we said that y is the number of boxes. So y equals, what's your rate of change? How many boxes do you start with initially at stage 0? Write the equation in slope-intercept form. Let's check in. Did you get y equals 2x plus 4? Excellent. That's what I got as well. Is this equation linear? Yes. The equation is linear. Equation is linear because written in, what form can it be written in? Slope-intercept form. Excellent. The next part it wants us to talk about is the graph. So let's take a moment and graph this relationship, this pattern. Stage 1 has 6 blocks. Stage 2 has 8 blocks. Stage 3 has 10. Stage 4 has 12. And stage 5 has 14. Should I connect my data points? No, I should not. Remember, this is called a discrete graph. I should not connect them because I can't have a partial stage number or a partial box. Think if that was cereal and we had to cut part of a box, there'd be cereal everywhere. So let's think about this. Is the graph linear? Yes. The data lies on a line. Yes, when graphed, the data lies on the line. Yes, this is linear. Now let's go back and look at our model. Justify your reasoning using the model. Is the model linear? Yes. The model is linear because it has what? What do all lines have? That's right, a constant rate of change. And because we want to be specific with math, 2 boxes per stage. Notice that this model is growing in one direction. That's important too. The pattern grows in one direction. So it's a linear pattern. Interesting. I'd like you to turn the page and look at what Design Team 2 has came up with. Looking at Design Team 2, can you draw Stage 4 and explain your process? Investigate Design Team 2 with your group and draw Stage 4. I'm going to give you 2 minutes. Go ahead and pause the video for 2 minutes for students to draw Stage 4 and explain their process. Okay, let's look at Stage 4 of your design. Notice from Stage 1 to 2, 3 blocks were added. From 2 to 3, 5 blocks were added. What happens with Stage 4? We increased the center section by 1 height and 1 width in dimension. Notice this isn't growing in just one direction like design team 1 was. So can this relationship between stage number and number of boxes in a stage in this pattern be modeled by a linear function? Let's create a table and graph to support our answer. I'm going to give you 3 minutes to finish working on 5. 3 minutes to work on 5. Please pause the video for 3 minutes so we can have a start with our groups on number 5. Excellent. Hopefully that was enough time to work on number 5. If not, please follow along. Our table is not linear because the difference between boxes is not constant as stage increases by 1. Interesting. Looking at our graph, our points don't fall on a line. If you were interested in what this equation is, the equation is f of x equals x squared plus x plus 4, which is nonlinear because the exponent's greater than 1. Don't worry, this year you're not expected to write that type of equation. Now let's look at our model. Is our model linear? Well, of course it's not. The model does not represent a linear pattern because the pattern grows in 2 directions simultaneously. The rate of change is not constant. I'm pretty confident you got that the rate of change was not constant, but something else that's important for us to note is that the pattern is growing in 2 directions simultaneously. It's growing in height and in width. Great job on finishing up to number 6 in this lesson. We'll take the rest of the class time to work on homework. Again, all class notes are posted on our Google Classroom. Do your best. Be nice to everyone.